So we have this rational function where n of x and d of x have no common factors. So we talked about making sure that there are no common factors, cancel out common factors first. The graph of f has vertical asymptotes at the zeros of d of x. So in other words, to find the vertical asymptotes, you need to set the denominator to 0. All right, let's talk about the horizontal asymptote. The graph of f has one or no horizontal asymptote determined by comparing the degrees of n of x and d of x. All right, when the degree of the numerator is less than the degree of the denominator, the graph of f has the line y equals 0, or the x-axis, as a horizontal asymptote. When the degrees are equal, the graph has the line y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator, or in other words, the ratio of the leading coefficients. And when the degree of the numerator is greater than the degree of the denominator, the graph of f has no horizontal asymptote. All right, I do recall that we completed example 2, part A. Did we complete part B?
No, ma'am.
Did we? Okay, good. Okay. All right, so we're gonna go with B. So f of x equals x squared plus x minus 2 over x squared minus x minus 6. All right, what should we do first based
You gotta
on,
factor.
yeah.
You gotta factor the denominator in the new. I think we did do this, Dr. Thomas.
Oh, we did?
Yes, but
Y'all
we
need
Yeah,
to
we
we,
do it?
did. We
we
stopped. You
did.
wrote a note on there where we
Yeah,
stopped
I got
it.
it.
All right. Okay, so let me go back through it just in case somebody missed it.
Okay.
All right, let's go back through it real quick. We factored it
Mm-hmm.
as x minus 1 times
X
x plus
plus
2
2. Mm-hmm.
over,
It was it x minus 3 and x plus 2.
yep,
Okay.
and then we cancel out the common factors. And we got x minus 1 over x minus 3, yep, remember that. And then, so this is what oh, yep, I remember, kind of, it's coming back to me now. And then we focus on this, and we set the denominator to 0. So the vertical asymptote is x equals what?
3.
All right. And make sure you put that x. And let me say this too. I kind of looked at a couple of y'all homeworks already. Monisha, let me see. Hold on. I didn't mean to do that. Hold on. Monisha, I think to everybody, there's a problem I noticed on there and on your homework, and it's not f of x, it's f of t equals something. You could recall what I'm talking about, Monisha? You got a homework problem. Yep, yep. So I wanted to address it. I'm gonna go ahead and address it. When I see things that I feel like is gonna be a problem for you all, I'm gonna try to address it before you get to it. So there's a homework problem in section 2.6 where it doesn't say f of x, it says f of t. So for the vertical asymptote, are you gonna say x equals, or should you say t equals if it's f of t?
T equals.
T
Yes,
equals.
t equals. Okay. So I think just warning you, when you get to the variable is a t and not an x, please put t equals the number for the asymptote, not x equals. All right. That's a little tricky one because you're not thinking about this variable. They changed the variable on you. All right. We got that? We good with that? I don't know what number it was. If Monisha, if you remember, you let us know what number it was, but it was one that I saw could be a little trouble if you don't recognize. What'd you say, Monisha?
It was number 11.
I can't hear you. Can y'all hear? Is your volume up? Okay, hold on. Number 11. Thank you. Number 11. Yeah, I did a Windows update yesterday, and now my button's not where it's supposed to be. Everything, so it's taking me a little longer to get the thing. So sorry, y'all. All right, horizontal asymptote. So what is the degree of this x minus 1? What is the degree of that?
1.
1. And what about the denominator?
1.
1. So they are equal. The degrees are equal. Therefore, what do we determine? How do we determine the horizontal asymptote? Do we remember? How do we determine? How would you explain it?
It would be 1 over 1.
And where does this one come from, and where does this one come from?
1 is from the leading coefficient.
Okay. Leading coefficients. So the leading coefficients are right here. 1x. All right. So the horizontal asymptote is y equals 1. Then remember, did I talk about a hole in the graph?
Yes.
Yes, ma'am.
Okay. There is a hole in the graph. Yep. At what number? At what point then, if y'all remember?
It's 3/5, -2 3/5, I think.
Yeah, okay, -2 3/5. All right.
Okay.
And we get that from the factor we canceled, x plus 2. We set x plus 2 equals 0 and solve for x. That gives us the x part. And then we plug that -2 back into this part right here. Just plug it back into this. So f of -2 equals -2 minus 1 over -2 minus 3. All right. We are going to move on to the next page. There is one more asymptote. It's called the slant asymptotes or oblique asymptotes. I usually say slant. Okay. All right. Find the slant asymptote. All right. So let's look at the degree of the numerator. What is the degree of x squared minus 4x minus 5?
The second
2.
degree.
2. Yep. What is the degree of the denominator?
1.
1. All right. Therefore, the degree of the numerator is 1 more than the degree of the denominator. All right. So, okay, maybe I wrote it down here already. Okay. Because the degree of the numerator is 2, exactly 1 more than the degree of the denominator, the graph of f has a slant asymptote. So, again, slant, when the degree of numerator is exactly 1 degree more than the denominator. What does that tell us about the horizontal asymptote? When the degree of the numerator is higher than the degree of the denominator. What does that tell us about horizontal asymptote?
There isn't going to be one.
There's no horizontal asymptote. Very good. So when you know there's no horizontal asymptote, there may be a slant asymptote. But the only way it can be 1 is if the degree of the numerator is exactly 1 degree more than the denominator. When that happens, we're going to use long division, or synthetic in this case. You can use both. So we're going to divide the denominator into the numerator. All right. So let's use long division. Let's see if we still remember long division. But of course, you can use synthetic as well. All right, x minus 3 divided into x squared minus 4x minus 5. X times what is x squared?
X.
Yep. Then we're going to multiply this x times the divisor over here. What do we get?
X squared minus 3x.
Correct. Don't forget, we got to do what?
Change the signs.
Yep, that's going to become a minus, and this is going to become a plus. All right, now what do we have? Negative 4x plus 3x. Negative 4x plus 3x
Negative
is
1x.
Negative 1x.
negative 1x. Okay. And then we're going to bring down minus 5. Now we start over. X times what is negative 1x?
Negative
1.
Negative 1. Negative 1 times x minus 3 is negative 1x plus 3. And we have to change our signs again. That's going to become a minus. Okay, minus sign. All right, that cancels. Negative 5 minus 3. We really don't care about the remainder, but let's go with it anyway. What's the remainder? Negative 8? Okay. All right. So the answer, the slant asymptote is, all right, we're going to put y up here. Y equals x minus 1. We can throw away the remainder for the slant asymptote. All right. Notice if you graphed y equals x minus 1 is a line. Here's the line right here. It's already graphed. It's slanted. This is the graph of y equals x minus 1. It's slanted. The vertical asymptote was x equals 3. The slant asymptote is y equals x minus 1. All right, again, ignore the remainders for slant asymptote. We are only interested in the quotient. All right. We're going to do one example. I'm going to take from the book, and then we're going to move on to 2.7. All right. This one example, I'm probably going to ask you a lot of questions, so it's probably going to take about 10 minutes. You might want to put this on another sheet of paper or on the back of your other paper, other notes. All right, let's pull up the whiteboard. It's taking a minute for some reason. Okay, let's create a new one. All right. So f of x equals x squared minus x minus 2 over x minus 1. Let's talk about asymptotes first. What would you do first? What would you do first? I'll say, what are the asymptotes? Anybody?
Would you factor the denominator?
Oh,
I mean, the numerator?
Yeah, let's see. Yeah, let's look at the factored version. Let's see. All right. So, because we want to see if there are common factors. Do we have common factors here? I know that's x times x. That's my contribution because I know that's x squared. What's the rest of the information?
X minus 2, x plus 1.
All right, x minus 2 times x plus 1. It's very important that y'all know how to factor in this class. As you can see, it shows back up. Now, here's the thing. Nothing cancels out. Y'all see that? There are no common factors. All right, so let's just, we could just focus on this. There were no common factors. It's the same thing. All right, tell me, what do we need to do to figure out what the vertical asymptote is?
Just set x minus 1 to 0.
Correct. Therefore, the vertical asymptote is someone other than Kenna.
1.
1.
I don't want y'all to say that.
Oh,
One.
x
Come on, guys.
equals 1.
Come
Y
on,
equals
smart
1?
class. Come on, smart class.
Y equals 1? You said vertical?
Vertical asymptote.
Oh, x equals 1. Alicia said it first, though.
X equals 1. All right. Let me get back to the whiteboard. Okay, here we go. X equals 1. All right. And then what about the horizontal asymptote? What are we looking at?
The degree.
Degree.
Okay, we compare the degree. Degree of the numerator is
2.
degree of the denominator.
1.
Therefore, horizontal asymptote, what can we conclude here?
2.
Mhm.
Equals, Y equals 2.
Are you sure?
Not since you said that, no.
Oh, you know by now. if the doctor don't say, "Are you sure?" I mean, it could mean. I may be just trying to see how confident you are. But class, what do y'all think? Monisha, what you think?
Yeah, she was right. Y equal 2. Is that right?
Is it? Is it?
So we look at the leading coefficient.
Are we?
I don't know. Oh, no, when n equals m, that's only the leading coefficient.
It will be the leading coefficient in the numerator over the leading coefficient in the denominator, right? It'll be 2 over
Okay,
1.
we
So
can't hear Monisha, but she's typing, y'all. Y'all, what did Monisha say? What did Monisha say? Monisha, send that to everybody. You just sent it to me.
it'll be 2.
All right, wait. Let's wait on Monisha's response. We can't hear her for some reason, but she's typing to me. All right, send that, copy and paste that to everybody, Monisha. Oh, y'all see what she said? I don't know if everybody got that, Monisha. You still sending it to
We
me.
got it.
Degree is
Come back.
Oh, y'all got it.
Um,
Okay. All right. She
It's
said the
slant.
degree is higher. Okay, do we have a horizontal asymptote then?
No.
No, when we have slants, we don't have horizontal asymptotes. The degree of the numerator is higher than the degree of the denominator. Therefore, we have no horizontal asymptote. All right, I know y'all got to learn it. Y'all got to memorize it. So we're going to put none. All right, slant asymptote. How do we find that? How do we find the slant asymptote? We just
You
went
can
over.
use long division or synthetic division.
Correct. All right, let's go with long, but you can use synthetic too. All right, so x squared minus x minus 2. X times what is x squared?
X.
Yep. And we multiply times a divisor. What do we get?
Negative X. No, negative 1. No.
Multiply times the entire
Yeah,
divisor.
X squared minus
X squared.
Yep. X squared minus x. That's what you said.
Mhm.
All right. Then we are going to
Change the
do a
sign.
minus. Uh-oh. I didn't mean to do that, y'all. Do a minus and a plus. That cancels. That cancels. It's weird. And so, so really it's like 0x minus 2. So this is our remainder. I know that because the degree of the remainder is lower than the degree of the divisor. So I can't divide x into -2. So what is the slant asymptote? We don't care about the remainder. What is the slant asymptote?
Y equals X.
Very good. I was looking for you to say why. That's why I asked you. I was testing you. I was testing you. Because I felt like somebody was say X. Y equals X. So because when you write Y equals a something, it represents a line. All right. What if I ask you some more questions like, what is the y-intercept? What would you do?
What's the denominator equal? No. Never mind.
How do you find the y-intercept?
Change f of x to y, and then swap the x and the y, right?
It's opposite what you think. Y-intercept, you do what? For what?
Plug in it for X.
Plug in what for x?
Oh, never mind. Nothing.
All right, I think Veterans Day hit y'all hard. It hit you hard. Let's not lose x-intercept and y-intercept information. All right, somebody,
Just tell us about the Thomas.
huh?
Just tell us.
Y'all know this. Find intercepts. Okay, how do you find the y-intercept?
Oh, you got to set it to 0.
Set what to 0?
The whole thing.
The denominator.
No, y'all, you set x to 0.
Okay.
For y-intercept, you plug in a 0 for x. For x-intercept, you plug in a 0 for y. It's the opposite of what you think.
I said that,
Plug in
Dr.
0.
Thomas.
I thought I heard x for x. I was like, what does
No,
that mean?
ma'am.
Okay. All right, that's why I asked you just say it again, because sometimes I can't. With the virtual stuff and the mics, and especially in class with the math, I'm like, what did you say? It's muffled. All right, so f of what again? What are we plugging in for x?
0.
0. All right. 0, 0, 0, 0. So tell me, what is the y-intercept? I want you to simplify it.
I got 2.
All right. So you got -2 over -1, which is 2. So the y-intercept is, how do you write that as a point?
0, 2.
0, 2. All right. So this graph is going to cross the y-axis at 0, the point 0, 2. All right. X-intercept, how do we find that? So it's opposite of what we just did. How do we find the x-intercept? How we find zeros then? Y'all, come on now. Come on, guys.
Set the
Wake up.
denominator to
Set
0.
Y equal to 0.
Set y to 0. Again, for y-intercept, thank you, Alicia, you set the x equals 0. For x-intercept, you set y to 0. It's the opposite of what you think you're supposed to do. All right. So that's why we're going to set this entire function here, x squared minus x minus 2 divided by x minus 1. We're going to set that equals 0 because we're replacing the f of x with 0. F of x is the same thing as what?
Y.
Y. That's why we are setting the function to 0. All right? I just put the 0 on the right side because I just like it on the right side. Now, what can we do now? We want to solve for x, basically. What should we do first?
Get rid of the denominator. Oh no, back to the
Yeah,
minus x.
You were right. What did you say first?
Get the denominator to 0.
You multiply both
Just type
sides
in
by
the
x
bottom.
minus 1.
Yes, multiply both sides by x minus 1 because we want to get rid of the denominator. I know it seems blasphemous, but we're going to do just like that, get rid of it. And then that's x squared minus x minus 2 equals 0. And then we already kind of factored it, didn't we? So we kind of did the work. We said it was x minus 2 times x plus 1. So x minus 2 equals 0 or x plus 1 equals 0. What are our x-intercepts? If I ask you to write it as a point, what would you say?
0, 2, and 2 and 0, and negative 1 and 0.
Yes. So those are additional points on your graph. And of course, those are not the only points you can use. You can plug in any number you want in this function to get additional points so you can get an accurate depiction of the graph.